Hello bachcho, let's read the question. Using integration, find the area of the region bounded by the lines 4x minus y plus 5 equals 0, x plus y minus 5 equals 0 and x minus 4y plus 5 equals 0. Solution शुरू करने से पहले let's note down the key concept for this problem. And now the key concept is area between the curves fx and gx such that fx is greater than or equal to gx for values of x in the interval a to b, and area in this interval is a equals integral a to b of fx minus gx times differential dx. And now with the help of this key concept we will now solve the problem. Ab question mein we are given two lines, right? So let's call L1 as line 4x minus y plus 5 equals 0. L2 is x plus y minus 5 equals 0. And line L3 is, so here we have x minus 4y plus 5 equals 0. Now let's draw the graph of these three lines. Now suppose here we have the coordinate axes. Line L1 has equation 4x minus y plus 5 equals 0. Now this line will pass through point when x is 0, y is 5. So here we have 1 point, and when y is 0, x is minus 5 by 4, and minus 5 by 4 is somewhere around here. So this point is minus 5 by 4, and so the graph will therefore look like this straight line. So this is line L1. Now let's draw line L2. L2 has equation x plus y minus 5 equals 0. And now let's get the points. When x is 0, y is 5. So this point. And when y is 0, x is 5. So that is this point. Now let's connect these 2 points. So this is line L2. Now let's get line L3. Now L3 has equation x minus 4y plus 5 equals 0. X minus 4y plus 5 equals 0. When y is 0, x is minus 5. So here, and when x is 0, y is 5 by 4, which is somewhere around here. So now let's connect these 2 points. So this is the graph of line L3. Now this region is the concerned region, and we need to get the area of this yellow region. And now to get the area of this region, we will divide this region into two parts. And divide in the sense, so if we draw the line x equals 0, that is the y-axis, we can see that the region is now partitioned into two parts. Let's call this part as A1 and the other is A2. We will first get the area A1 and then A2. And before getting the areas, let's first get the intersection points, this and this. That is intersection point of L1 and L3 and intersection of L3 and L2. So first let's get intersection of L1 and L3. So the equation of L1 is 4x minus y plus 5 equals 0. Equation of L3 is x minus 4y plus 5 equals 0. Now let's multiply the equation of L3 by 4. So this gives us 4x minus 16y plus 5 times 4, that is 20 equals 0. Now simultaneously solving, we get value of x as, so value of x is minus 1 and value of y is 1. So the intersection of L1 and L3, that is this point, is minus 1 comma 1. Now let's get the intersection of L2 and L3. Equation of L2 is x plus y equals 5 and equation of L3 is, So here we have x minus 4y equals minus 5. And now simultaneously solving these two equations, we get value of y as 2 and value of x as 3. So the point has coordinates 3 comma 2. And so to get the area A1, we will vary the value of x from -1 to 0, and then to get area A2 we will vary value of x from 0 to 3. So therefore area A1 will be equal to integral from -1 to 0 of the upper boundary is line L1, and line L1 has equation. So here we have y equals 4x plus 5, and the lower boundary is line L3, which has equation x plus y divided by 4 equals y. So here we have 4x plus 5 minus x plus 5 divided by 4 whole times dx. Now let's simplify. Here we have integral -1 to 0 of 4x plus 5 minus x by 4 minus 5 by 4 times dx. So now simplifying, we get this is equal to integral -1 to 0. So 16 minus 1 15 x by 4 plus, so this is 15 by 4 dx. And now let's simplify and integrate. So this is 15 by 4 and integration of x plus 1, that is x square by 2 plus x over the limits -1 to 0. So when applying the upper limit 0, we have 0, and applying the lower limit, so this is equal to minus of 15 by 4 times 1 by 2 minus 1, and this evaluates to, so this is minus half times minus 15 by 4, this is 15 by 8. So A1 equals 15 by 8 square units. And now let's get the value for A2. A2 will be integral from 0 to 3. The upper boundary is line L2, and L2 has equation y equals 5 minus x. So therefore we have 5 minus x minus the lower boundary, and that is x plus 5 by 4 times differential dx. Now let's simplify. So this is integral 0 to 3 5 minus 5 by 4 minus x by 4 times dx. This is integral 0 to 3. Now this is 20 minus 5, that is 15 by 4 minus, so here we have minus 5 by 4 times x dx. And now let's simplify and integrate. So this is equal to 5 by 4 common, and we have 3 minus x. So integration of 3 minus x is 3x minus x square by 2. Limits are 0 to 3. Applying the upper limit, we have 5 by 4 times. So this is 9 minus 9 by 2, that is 9 by 2 minus the lower limit is 0. So this is 45 by 8 square units. And so finally area of concerned region is A1 plus A2. A1 is 15 by 8, A2 is 45 by 8. This is equal to 60 by 8, and so this is equal to, simplifying we get, so this is 4 15s and this is 4 2s, so this is 15 by 2 square units. So area of concerned region is 15 by 2 square units, and this is our final answer. I hope you understood it well. Best of luck and thank you.